So in our last example, we looked at throwing this little fella 4 times, and we've got a 1 on 3 of the sides, but not a 1 on the fourth one. And these were called Bernoulli trials. Each time we threw that and had a look what happened, it's a 1. And we formed a binomial distribution of probabilities because of this. And we looked at x, the random variable, and it's a discrete one, as describing the number of ones we get in the 4 trials. So we might have got no ones. We might have flipped this to get that every single time, all 4 times. And if that's the case, this is what we got here. And we used a tree diagram and we worked out all of these here. So the chance of getting 4 ones was 3/4 to the power of 4, because the chance of success is 3/4. There's 3 ones on there, and only 1 of the 4 has no ones. So the probability of success was 3/4, and the probability of failure is 1 minus 3/4. 1 minus the probability of success, which is 1/4. This has to be the case, has to be a Bernoulli trial each time you throw that, and the probability of success and the probability of failure have to add to 1. We noticed that it was like expanding out this binomial, where you've got a 3/4 plus 1/4 to the power of 4. Notice that they equal to 1. So of course it adds to 1. 1 to the power of 4 is 1. But we're going to expand that out. There's your success, put at the beginning. There's your fail, put there. You can put them the other way around. It's still going to work. We know the symmetry of the way these expand. But let's just keep it consistent and always put our success at the front and our failure second there and expand away. If you expand this now, you get 4C0, 3/4 to the 0, and 1/4 to the 4. Now, most people just write down 1/4 to the 4, but do realise that it is actually 3/4 to the 0 in there as well. It's just that equals 1, so we don't normally write it. And 4C0, that equals 1, so we don't normally write that in there. But it's there. Success is the first number here. No successes. 4 failures, doesn't worry me. But these 2 numbers always add up to 4. We know that from our expanding the binomials. All right, we move along to finding the chance that x equals 1. So 1 success, therefore 3 failures, because there's 4 trials. 4C1, 1 success. 3/4, your success probability to the 1. And 1/4, your failure probability to the 3. And 4C2, 4C3, 4C4. And we just move our success probability 2, 3, 4, and our failure probability to 1, 0. Once again, this one here, you often just write the 3/4 to the 4 because these 2 guys just equal 1. All right. So just in general, with this binomial probability, where you have Bernoulli trials and success or failure, and that's all you've got, and they're complementary probabilities, the probability that x equals x, the probability your random variable is like 0 heads or 1 or 2 or 3, probably that equals whatever you decide, is the number of trials, like the number of throws, C, the number of successes you're looking for, your success to the power of the number of successes you're looking for, and your failure probability to the number of trials minus that. So that's a formula. Do you need to learn that? Fortunately, no. It's written on your formula reference sheet for the HSC. However, they don't tell you what it means. It's just blankly written there. So you need to know X is the number of successes, and N is your number of trials. It's your number of Bernoulli trials. How many times you, in this case, throw this thing? How many times you throw the dice? How many times you throw a coin? So we're going to use that formula to make life a bit easier, now we know that that's what's behind the whole situation. Instead of having to expand out every term, you can just decide which term in there you want, how many successes you want. Do you want just 2 ones? Well, then you need to go straight to this term. 4C2, 3/4 to the 2. And then it'll be a quarter to the 2 as well because there was 4 trials.